Hi everyone, welcome to Byte and Beyond with Uday. In this video, we are going to learn about Singleton Design Pattern. So, our first step will be what is Singleton, alright? Second step will be why it is important. And in the third step, we will implement the actual Singleton Design Pattern with the real world example, alright? So, let's begin. So, Singleton Design Pattern comes under Creational Design Patterns category. Now, what is Singleton? Singleton meaning we need to create only one object of particular class. All right. Let's say I have a class configuration manager. Now, I want to create only one object of that particular class. So, in that case, I can use Singleton Design Pattern that helps me how to how I can make sure that only one object will be created. All right. So that is singleton, where we make sure that only one object will be created, and that object will be shared across the application. So if you see this slide, we have only one object of this class, and that is shared or used across the services: service A, service B, service C, and service D. All these four services using the same object. All right. So if I go to the next slide, why it is important? All right. As I mentioned, whenever we have a requirement or we have a need, that we don't need multiple objects of particular class. For example, you can take a service, any service, or for example, you can take a example of configuration. All right. So configuration manager, I don't need multiple objects to manage the configuration. I need only one object. All right. So I want to make sure that for the configuration manager, I should be able to create only one object. But how can I do that? So for that, our singleton design pattern is useful. All right. So whenever there is a requirement to create only one object, all right, whenever there is a requirement to create only one object, then we use the singleton design pattern. So you can see the simple definition or simple one liner over here. Use singleton when the application needs one shared instance of a class. All right. You can see here is the logger example over here as well. We need only one logger object and we are done. Same for the caching, same for the configuration, and same for the shared resource. So we are done with the theory. Let's do the hands-on. All right. So let me create one class over here. As I mentioned, let's take a real world example. Let's say configuration manager. Right. Okay. So you can see I have created one class. Now I have created one class, but over here, let's say few methods. All right. For example, add config. All right. Add config. And I'm just, printing few sysout statement over here, configuration added. At the same time, let me enable my Gen AI so it will help me to code faster. All right. Okay. So, and one more method, let's say get config. It will return a configuration. All right. Cool. Now let me create one class, tester class, where I can use where I can use this singleton. this configuration manager. All right. So let me create one main method. Okay. So what I will do for now, let's see the problem. All right. Then we will apply the singleton design pattern. First, let's understand the problem. Then we will apply the singleton design pattern. All right. Okay. So you can see I have created configuration manager class over here using the new keyword. So it will create an object for me. All right. And I am adding configuration and I am getting configuration. So if I run this, it will run perfectly fine. Configuration added. And this is the configuration we got. All right. From the configuration manager. What I can say, make it interesting. Something, you know, yeah, configuration retrieved, for example. All right. Now, let's say somebody in your application creating another object, configuration manager 2. All right. So this also works fine, but we have a problem over here. What is that problem? You can guess. Over here, we have created two object of this configuration manager class. So if I compare configuration manager is equal to configuration manager 2, it will return false because these two are different objects. You can say false, meaning I have created two different objects. So how can I limit this? All right. How can I limit this? So you can see I can create an object using the new keyword. So what I can do, as of now, we have default constructor. All right. Compiler adds default constructor for us. By default, whenever you create a class, the Java puts a default constructor like this. All right. Like this default constructor. But this is public. So what I want to do, I want to declare this constructor as private. So nobody from outside this class can create an object. All right. So once I declare or once I create the private constructor for our configuration manager, all right, I can't create an object. You can see I'm getting a compilation error because this constructor is private. So over here, I have blocked outsider to create multiple object of this configuration manager. This is the first step. All right. So now question arise, if I'm blocking the if I'm blocking the creation of this object from outside, so how how somebody is going to use this class? What is the meaning of it? How I can provide an object? So to answer that, we need to provide a static method over here. All right. So as you know, static method, we can access the static method using the class itself. We don't need an object. All right. So that is why we need to declare the static method over here. Correct? Perfect then. So you can say hmm, this is the static method. I am returning the configuration manager. All right. Now what I will do, I can create return new configuration manager. All right, but still we have a problem. All right, if I if I call get instance two times, I will get a two objects. All right, so to prove that, let's take a same example, configuration manager get instance. All right, configuration manager. Okay, so you can see instead of using new keyword, I am using get instance. All right. So we will see this time. All right. We will see. Still, we will getting false because each time I call the get instance, you can see false. Each time I, uh, you know, execute or call this method, each time I am creating a new object. So I don't want that. What I will do, I will create one static variable. All right. Why static variable? Because we have a static method and it can only use static variables. So you can see I have created one. What I can say. Let me remove. Let me disable. Let me disable this inline completion. Disable. Next edit suggestion. Okay, it is bothering us while doing coding. Okay. So what I have done over here, I have declared one static variable. All right. This is the variable of this class. All right. Now what I will do, I will put a if condition over here. If instance, if this instance is null, all right, then then I will create an object. I will assign to it, and then I will return it. All right. So return instance. Perfect. Now Now let me run this class and you will see, you can see I'm using the same method get instance, but instead of blindly creating an object each and every time whenever somebody is calling this method, I have added null check over here and I'm using this static variable. So what I will do, some if somebody is calling for for the in this example over here I am calling get instance. So what it does, first I will check instance, this static instance variable is null. If it is null, then I will create an object and assign to this variable and I will return the variable. All right. So the next time somebody calls, so if you see, this is the next time, this is the second time I am calling this get instance. So this time what will happen? This condition will become false. All right, why? Because we have already assigned an object to this static variable. So I won't go inside this if condition, and instead of that, eh, rather than going inside this if condition, I will skip the if part and directly return the instance. So let's see. This time we will get the true. All right. So let me run this. You can see true. Why? Because it doesn't matter how many times I call the get instance, I will get only one object of this particular class. So you can see, because these two objects are same, all right, they are pointing to the same memory location of object. So whenever you create an object, it gets stored inside the heap memory, and this variables call stores the memory location. All right. So let's say over here we have a first it's called, let's say, memory location 123. All right, memory 123. So if you call the second time, it returns the same object. This variable also has the memory location 123. All right, and this object is stored at memory inside the heap memory at address 123. All right. So when you compare these two address, memory 123, memory 123, so what it will return? It will return true because this both reference variables pointing to the same address of this configuration manager. All right. So this reference variable does not store the object. Instead of that, it stores the memory location of that particular object that belongs to the heap memory. So our object, for example, belongs to the memory 123. All right. And when we compare this, these two addresses are same, and hence it is returning true. But over here we have a problem. So you have a single thread or only one thread application. All right, this is safe. There is no problem at all. But in the real world example are not, or real world application are not single thread application. All right, there are multiple threads running at the same time. There are multiple threads, 10 threads, 100 threads, 1000 threads. All right, accessing the same method at the same time. Let's say we have a thread A and thread B. Both threads are accessing this method, get instance method, at the same time. All right, so what will happen? Both thread will read that instance is equal to null. All right, now both thread will execute this line as well. So if two threads are executing the same line at the same time, we will again ending up creating two objects. All right, so in singleton design pattern we have double check, um, we have a double check facility. All right, or we have double check feature. All right, that makes our implementation thread safe. So let me implement this. Our first line will remain as it is. All right, but to make it thread safe, what I will do, I will add another if block. All right, but before I add the another if block, I need to do something. I need to add synchronize block over here, and I need to pass this object or pass this class. All right, now over here you can see I have declared the synchronized block, but still it is not enough. I need to add one more if condition. It will do the same thing. It will again check instance is equal to null or not. All right, if it is null, we will create an object. All right, so if you see over here what I am doing, so let's say again take the same example, two threads at the same time. So it both threads reads instance is equal to null. Both threads enter inside this if condition. All right, now whenever we have a synchronized block, all right, whenever we have a synchronized block, so synchronized block make sure that only one thread, all right, only one thread can access this block at a time. All right, so let's say thread A enters inside this block and it reads. Thread B is waiting outside block, all right? Because synchronized block make sure that only one thread can access this code. So let's say thread A enters inside the synchronized block. It checks. First it checks instance is equal to null. Yes, it is null. Then thread A will create an object and it will assign that object to this variable and then it will return. All right, so thread A execution completes over here. Now the thread B was waiting outside this block. Over here, thread B was waiting. All right, thread B waiting. All right. Now thread B was waiting over here. Once after this, after this synchronized block, thread A finish this synchronized block and it returns the instance. Now thread B thread B enters inside this synchronized block. All right, because thread A work is done. Now thread B checks instance is equal to null. No. Why? Because instance is already initialized by thread A. So it won't go inside this condition, if condition. All right. and it will return the instance. So, so over here, even though we have two threads accessing this method at the same time, but we have make a door over here, a kind of get that makes sure only one thread can access this block at a time. All right. So if I run this class, still it will work. It will return true. Configuration manager is equal to configuration true. It will return true. All right. You can see true. Same object. But we have a small problem over here. Or I would say we have a small limitation. You can see this variable. All right. You can see this variable. This variable is non-volatile, meaning thread A, thread A maintain its own memory cache. Thread B maintain its own memory cache of this variable. All right. Now thread A comes, instance is equal to null. All right. It will create an object, but instead of now instead of using using the this instance variable of in main memory, the thread A maintains or cache this inside the. So for example, let's make it simple. Thread A has its own memory. We call it thread cache. Now thread B has also its own memory, thread B cache. Now when thread A creates an object, it maintains that data inside the thread cache. All right. So thread A initialize and stores this inside the thread cache only. Now thread B comes. So for thread B, it is still null because thread A maintaining this instance variable or the static variable inside its cache. All right. So for thread B, it is still null. So thread B again, even though we have make it synchronized, thread B again creating a new object, and again we will ending up with the two objects or more than one objects. All right. So how can I prevent threads to using their own cache memory? So for that we have volatile keyword. All right. So volatile keyword will force thread to do not use their own cache, instead of it will use the main memory. All right. So what will happen? Now thread will stop using their own cache memory. Now thread will use main memory. So what will happen? Let's say thread A enters. Now thread A creates an object. Now once it creates an object, it updates inside the main memory. All right. Now thread B comes. Thread B read this from the main memory instead of its own cache. Thread B reads this static variable from the main memory. Now thread B can also see, yes, this is already initialized. So instead of going inside this if block, it will return this instance. So it doesn't matter how many thread comes, only one thread will enter. All right. Initially, only one thread will enter inside this synchronized block. It will see instance is null. First thread will create an object, and it will update this static variable inside the main memory because of this volatile keyword. All right. And then first thread will return the instance. Now second thread comes. Second thread reads this static variable from the main memory. It checks that it is already initialized. It is not null. Hence, it won't go inside this if condition, and it will return this instance. Now let's say thread 3, 4, 5 comes. So what will happen? Those threads won't go inside this synchronized block. Instead of that, we have first if condition. All right. So let's say thread 3 comes after some time. It checks instance static variable. Is it null? No. It will read the instance from the main memory. because we have declared the volatile keyword. It will read the instance static variable from the main memory and it will check, is it null? No. So it will directly return the instance. So what will happen? It doesn't matter how many thread comes at the same time. All right. We are not queuing those threads. All right. Instead of that, we are just, those thread will read this if condition and directly return this instance. So we are not, compromising the performance over here. Initial performance will compromise. So if this instance is null, all right, and let's say 10 thread comes at the same time. So all of these 10 threads will come inside this synchronized block one by one because they have already cleared this. So let's say thread 10 comes 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10 all at the same time, all reads, instance is null. Now all are waiting or all are accessing this block one at a time. First thread 1 goes, it will create an object, all right, and it will return. Now thread 2 comes, object is already created, then it will return. Now thread 3 comes, it also reads, all object is already created and then return. So this first initial thread will, observe the performance impact because they came at the same time when our object was not initialized. All right, our instance variable was null at, at initial point. So first 10 threads will see performance impact, but let's say another 50 threads or 100 threads came afterwards. So what they will do, they won't go inside this if condition because we have added the first level check. They only read the first level check, is it null? No. So it will skip whole this if block and it will return the instance. So it doesn't matter how many threads comes at the same time afterwards. We want observe the performance impact because of this first level check. All right, it does not go inside the synchronized block, and if it is already initialized, it will directly return the instance. All right. So to prove this, all right, let me do few things. Um, let me create few objects. All right. That's a configuration manager, configuration 3. All right. Again, configuration manager, configuration 4. So it doesn't matter how many times I compare, all will return 3. All will return true. All right. So even if I say configuration 4, all right, I am comparing all of these objects memory location. It will all return true. All right. Let's see. You can see all return true. It doesn't matter. I can compare configuration 3 and 4 as well. It doesn't matter which one I compares. It always return true because we have made sure that only one object will create it. All right. So this is the purpose of creating an object. So we can use same object across the application, and we can this utility methods add config, get config across our application without creating multiple objects. All right, and that this is how this is how singleton design pattern works, and that's how you can this is how you can implement the singleton design pattern. And applying the singleton design pattern, you make sure that only one object will be created of your class. All right, but still this design pattern has some limitation. I will give you the hint: reflection. Reflection can break our singleton design pattern, but we will see that in the next video. For this video, this is enough. I hope you have learned something new. All right, and this is, by the way, this is called lazy initialize singleton design pattern because we are not upfront creating an object. We are creating an object whenever somebody is calling get instance method. All right, that is why it is calling lazy initialization. We are creating an object as per the ask. Without ask, we are not creating any object. So that is why it is lazy initialization singleton design pattern. All right, and it has a limitation. Reflection APIs can break our singleton design pattern that we will see, that we will explore in the next video. For this video, this is enough. I hope you have learned something new today. And if you find my video useful, then please like, share, subscribe, comment. See you in the next video. Till then, goodbye.